to read something, okay? So I need you to read a paragraph each. Can we do that? Really loud so we can see it in the camera. So I'll start. The English word sequence comes from the Latin word sequi, which means to follow. If a group of numbers is arranged in a definite order so that one number follows another number, we say the numbers have been arranged sequentially and that the numbers form a sequence. You've heard of sequences before, right? On the left, we show 6 numbers in a random pattern. We say that these numbers are arranged non-sequentially because there is no sequence to follow, or they don't follow a pattern. On the right, we show 2 of the many ways these 6 numbers can be arranged sequentially. If a sequence,
If a sequence has a finite number of members, we say that the sequence is a finite sequence. Sequence A and B have 6 members and are finite sequences. We write 3 dots after last entry to indicate that a sequence has no end, as we show in sequence C below.
And sequences with no end are called, obviously, infinite sequences, right? Because they have no end. So,
subscripted variables are often used to designate the members of a sequence. The letters most often used for the variables are X, Y, A, S, and T. When T is used, the author often indicates that the letter is an abbreviation for the word term. We could also use T to indicate the terms of any 8-term sequence by writing
T1, T2, T3. Skip a line, and Ivan, can you read where it says the English word progression?
The English word progression comes from the Latin word progredi, which means to go forward. In mathematics, we use this word to describe a sequence in which each term depends in some way on the term that precedes it. An arithmetic progression, or arithmetic sequence, is formed by choosing a first term then adding the same constant to form each succeeding term. Thus, each term in an arithmetic progression is greater or less than one that precedes it by a given amount. We call the difference between terms a common difference, and any sequence that has a common difference between the terms is an arithmetic sequence. Each term in A is 3 greater than the preceding term. Thus, the common difference is plus 3.
Okay, so let's see, and we'll stop reading. So, if we have 7, 10, 13, 16, 19, 22, we know because they have a specific order, they go from least to greatest, that there is a pattern there. What is the pattern? You add 3 every time, right? Plus 3, plus 3, plus 3, plus 3. Because this one depends on this one plus 3, and this one depends on this one plus 3, it is also not just a sequence, but an arithmetic sequence. Because it depends on the one before, and because it has a common difference. What is that common difference? The plus 3 that you add to each and every one, okay? Since we can go a step further and say that this is 7 plus 3, and this one here is 7 plus, this one here is 7 plus 3 plus 3, right? This one here is 7 plus 3 plus 3 plus 3, and so on. We know from way back that there's a short way of writing when you add the same number over and over and over again. What is that short way?
Multiplication.
It's a multiplication. So this one would be 7 plus, let's call the difference D, okay? Oh no, let's call it 3. And then this one would be 7 plus 2 times 3. And then this one 7 plus 3 times 3. And the next one, even if I don't have it, I know it will be 4 times 3, and so on, okay? If I call this first one, I'm going to call it a sub 0 or 1, what do we call it? It's 1. If I call this one a sub 1, this one's going to be 2, 3, and so on, right? Knowing that, how can I make a general formula for an arithmetic process? Because they're all going to be the same. This one, instead of calling it 7, I'm going to call it what?
Ace of one.
Ace of 1. Plus, and instead of calling it 3, I'm going to call it the difference, okay? So it's going to be D. This one here is going to be Ace of 1,
plus 2 times D. 2D.
2D,
A1 plus 3D.
and so on, right? But I'm going to put a 1 here. I'm going to have to make it more general. How can I make it more general?
A1 plus
Uh-huh.
A.
And this is A1, right?
A plus
A1 plus,
parentheses
uh-huh.
N minus.
What is N?
The number on the.
I need him just for like 5 minutes. Okay,
Is it the 7?
if this is Ace of 1, this one corresponds to Ace of 2, right? And this one corresponds to Ace of 3, and so on. Now, notice that this 3 is not this 4. This 2 is not this 3. This 1 is not this 2. If we call this one, if we call a little number underneath N, what would this one be? Minus 1 every time, right? Times D. So what happens with the first one? Is it true for the first one also? Yes, because if it's the first one is Ace of 1 plus 1 minus 1, which is 0, times D, this goes away and I'm left with Ace of 1. So you are correct. The general formula is for an arithmetic. I always have trouble with that. Arithmetic progression or sequence, they're synonyms, is Ace of 1 plus what?
Plus N minus 1 times D.
Times D. So Ace of N is going to be Ace of 1 plus N minus 1 times D. So, in general, where Ace of 1 is the first term in the sequence, right? N is the term number. And D is the common difference. So, let's try this out. Questions so far? Is there something that doesn't make sense? A number you don't know where it came out of? Something? No? We're good? Okay. I'm erasing. Okay. So, let's try write the first 4 terms of an arithmetic sequence whose first term is minus 14. If that's the first term, what do we call it? Is 1. And whose common difference is 10. What do we call that? D. And you want to find the first 4 terms. So you need Ace of 1, Ace of 2, Ace of 3, and Ace of 4. That's what you're looking for. First 4 terms. Ace of 1 you've got as a given. Ace of 2.
Ace of 1. Minus 14 plus.
I'll write it downward. Ace of 2 is going to be
Minus 4.
Ace of 1 plus 2 minus 1, right? Times 10, which would equal minus 4. Ace of 2, Ace of 3, minus 14 plus 3 minus 1 times 10, 6, and Ace of 4, minus 14 plus 4 minus 1 times 10, 16. Okay.
You could just have that.
Yes.
Yeah,
Is
that's
it
the-
clear?
Test.
how to do that. Okay, let's keep going. They are each, the terms between the end terms, meaning if I have a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5, for example. It's a finite sequence. These three in the middle are called arithmetic means. Or I can't say arithmetic, means. Okay? Any term in between the first and last terms are called arithmetic means. Okay? So, if we look at problem, example 86.3, it says, insert 3 arithmetic means between 2 and minus 4. And you want 3 in between. So that means you want a sub 2, a sub 3, and a sub 4. Correct? Because you want 3 arithmetic means. So, what do we have? What information do we have with this that we have here?
The first one.
So we know that a sub 1 is 2. What else do we have? Do we have the difference? Not yet. We have to find it. How can we find it? Because like you said, we have a sub 5, which is minus 4, correct? And we know that minus 4 is equal to what?
2 plus 4, 5 minus 4. Times b.
So the only thing you don't know is d. You can find out d. We know that this is minus 6 divided by 4. So your d is now 3 halves, negative 3 halves. So now we can find a sub 2. Because it's going to be 2 plus 2 minus 1 times d, which is negative 3 halves. And a sub 3 and a sub 4 consecutive, right? 2, 3 minus 1, 4. 4 minus 1. Okay? Questions? We're good? Trying to make this as short as possible.